Hello, welcome to me and Jarrett's final design project for a Pico hydropower system. So a little bit of background for our design. We chose Dark Hollow Falls, which is in Stanley, Virginia. We chose this location because it's a relatively small waterfall, so it's a good resource for a Pico hydropower system. And it's also a really small town, which is a good use case for the power that we can develop here. So kind of starting out, the main assumption that we had to use was the total height of the waterfall, which we estimated to be about 0.5 meters. I've been there, so I think that is a pretty good approximation of the height of the falls. And so once we got that assumption, we were able to go from there and calculate our velocities at various points in the falls. And then from there, we were able to calculate the velocity of the wheel. So we decided to use a Pelton wheel because we thought it was a good use case for this situation. It is a relatively easy design and efficient. And we found some good examples on power spout that we could use for this system. So we were able to calculate the velocity of the water after the wheel, and then from there the mass flow rate, which was pretty simple. And then from there we were able to calculate the power output, which we estimated to be about 1.7 kilowatts, which is a good approximation because it fits within the bounds of a Pico hydropower plant.
All right, so this is the CAD design of our Pico hydropower plant. If you look to the figure on the right, you can see where the water jet that is formed from funneling in the flow of the waterfall. This comes in on the left side of the wheel. That's going to be underneath of the waterfall, like I said, and then that's going to turn the whole contraption, which if you look at the arrow in the bottom right-hand corner, it shows how the output power shaft will turn and deliver power to the generator. So our wheel is sort of a unique design. It's a blend of a Pelton wheel and a classic water wheel. I say that because there are 16 buckets, but you see that each of them is connected to a long arm that's then welded to the main inner housing. That kind of makes it look like your classic, just regular water wheel. But then at the end of each arm, we have a Pelton bucket. We have 16 buckets that each have an exit angle of 165 degrees. We know from class that in reality, you get a maximum efficiency from an exit angle of 165 degrees. So that's what we went with to have the most efficient power production. And then to save weight, instead of having a massive solid wheel in the middle that each bucket is attached to, we just made a longer arm that goes out to each bucket, so it's not a ginormous solid thing with a massive moment of inertia. There's a much lower weight, and we'll be able to create more power more efficiently this way.
So in conclusion, the power plant would fit well within the definition of a Pico plant because our output was roughly 1.7 kilowatts. And it would fit well within the environment because it's a pretty remote area and it wouldn't disrupt the natural environment. I think we'd be able to make a system small enough that it wouldn't be too burdensome for the environment and it wouldn't change a whole lot of the surrounding areas. The main thing we would have to do is we'd have to build like a small dam around the outer edges of the waterfall just to ensure that there wouldn't be water overflowing off the other sides of the waterfall. But overall, I think this would be a pretty good system for our design. Thanks for watching.